The new chapter for the session is chapter number 6, which is lines and angles. As we have discussed in the previous chapter about Euclid's contribution to geometry, we have come across various axioms, postulates, and many things connected with lines. So those properties of lines which you have studied in Euclid's contribution is what we're going to extend in learning the connection between lines and angles and various further properties connected with lines and angles. As we have discussed that a line is a unique line which passes through two distinct points, now comes how an angle is connected with the line is what we are going to discuss in today's session. The lines connected with angles. As we all know that angle is part of two lines, we know what an angle is. So let's see how we connect an angle with the straight line. Imagine I have two lines which are intersecting, the line L1 and the line L2 intersecting at this point. Now my question here is, what is an angle? How many possible angles are existing when these two lines L1 and L2 are intersecting at a point P? I find that there is an angle out here, there is an angle out here, there is an angle out here, and there is an angle out here. So totally there are four angles, 1, 2, 3 and 4 is how I understand the lines intersecting to form angles. There are angles out here which are formed by the two lines intersecting. Let's see the continued properties connected with lines and angles as introduction, continued with the session. Now that we have learned about the introduction of lines and angles, there are some basic terms in the topic which we need to understand before we get into the concept of lines and angles. The basic understanding of the basic terms. So let's see what are the basic terms as used in the topic lines and angles. Initially with the basic terms as used here. Now as that we are defining a line or an angle which is derived from a line, the source of an angle is a line is how I understand. Therefore, it is very important that we understand the different forms of line representations. Say for example, I have a line which is this, with the endpoints A and B. Then this is called line segment AB. I call this as line segment AB is how I understand this. Next, say I have a point A but I don't have the end on the right, or I have point B and I don't have an end on the left, or I have point C, or I have none of the points in between but it doesn't end on the right and left. These kind of lines which do not end on the either side or on the both sides. Here it doesn't end on the right, here it doesn't end on the left, and here the line doesn't end on either side. Such lines are called rays. I call them rays. A light ray which passes, imagine I take a torch and pass a light ray, it never ends, it goes on and on. So we call this as a ray. The right ray, the left ray, the two end ray is how we define the subterms. So it's very important that we understand the line segment AB and the rays AB before we understand the line AB. Line AB is a line which can be a line segment or a terminated ray on one side or non-terminated on either side. Is how we understand the basic terms which are essential in connecting lines with angles. Now that we have seen some basic terms essential for understanding lines connected with angles, it's also important to understand some extended basic properties like the collinear points or the non-collinear points on the line. So what are collinear and non-collinear points is what we're going to discuss in this session. Collinear points. When do we say collinear? When they are linear to each other. So when are the points linear? If all the points lie on the line, they are collinear. If all the points do not lie on the line, they are not collinear. It's very simple. The word collinear itself says they are linear, therefore we have collinear implies all points must lie on a line. Then only we say the points are collinear. Say for example, I have a line, or this is a ray in which I have 3 points P, Q and R. Let's see if they are collinear. Clearly I have the point P on the line L, and I have point Q which is on the line L, and the point R which is on line L. So since PQR lie on line L, therefore they are linear to each other. Therefore PQR are called collinear points on L. The points are collinear if they lie on the line L. They are not collinear if they do not lie on the line L. Is how we understand collinear points connected with lines and angles. Let's see an example of a situation where we have non-collinear points. For example, I have a triangle ABC. I clearly see that if I take this line L, A and C lie on L, but B does not lie. Since A, B, C do not lie on the same line, since A, B, C do not lie on the same line, therefore A, B, C are non-collinear. Is how we understand the non-collinearity of the points. The 3 points must lie on the line L for the 3 points to be collinear. If one of the point does not lie on the line, though the other 2 points lie on the line, all the 3 points are said to be non-collinear. Non-collinear do not lie on the line. Collinear, the points lie on the line L, is what we learn as the learning outcome. Now that we have learnt some basic terms and properties in lines and angles, now comes the essentiality of recognizing the different types of angles involved when two lines intersect. Types of angles is the session about. Types of angles. Now that we have seen two different lines intersecting, we have them intersecting in different ways. Say for example, I have the two rays. In the first case, passing from P, I clearly see that this angle, if I represent with theta, is less than 90. So any angle which is less than 90 is called acute angle. Say for example, I take this as x. So if the angle is less than 90 and greater than 0, then I call this angle as acute angle, is how we understand the formula number 1. Secondly, if I take a line which is exactly perpendicular to the other line, so ray 1 and ray 2 are perpendicular, then this x equals 90, then x is called right angle. If the angle is 90, that angle is called right angle. If the angle is less than 90, it is called acute angle, and if the angle is greater than 90 is what we are going to discuss further. An angle greater than 90 degrees. Let's investigate. If this is x, then any angle which is greater than 90 and less than 180, an angle which lies between 90 and 180 is called an obtuse angle. Is how we see the three different cases of an angle: less than 90, acute, equal to 90, right angle or perpendicular angle, and between 90 and 180 it's obtuse angle. So for these two lines or the rays, the angle is obtuse because it is more than 90 and of course less than 180. These two lines make an angle of 90 degrees because they are exactly perpendicular to each other. These two rays are obviously less than 90 degrees and therefore such angles are called acute angles. Types of angles connected with lines and angles: acute angle, right angle, and obtuse angle. Now that we have discussed about the types of angles, acute, right angle, and obtuse angle, now let's take two special cases which are very important. What if the angle is more than 180 degrees? Is how we investigate two special cases. Types of angles taken as special cases. Now in this case, as we have seen that an angle less than 90 is acute, when x is 90 it's right angle, more than 90 and less than 180 is obtuse. Now comes the investigation on what happens if the angle is 180 or more than 180 as special cases for types of angles. Let me take the first case of 180 degrees. Say for example, I have the two rays which make an angle of 180 degrees. So when the angle is 180, then that angle is called straight line angle. So such a line is called straight line angle. is how we define for 180 degrees. Similarly, what happens if the angle is more than 180? Say for example, I have an angle this which is more than 180. So have this to be between 180 and 360. So here I have an angle more than 180 and less than one full circle. So such a case, X is called a reflex angle. That's how we understand the straight line angle and reflex angle which are more than 180 and equal to 180. X equals 180 degrees implies that angle is called straight line angle as made by the two rays. X greater than 180 and less than 360 called reflex angle. Straight line angle and reflex angle as the special cases of the types of angles. What if the angle is 360? If suppose, let me end with the last angle which is 360 degrees. If the angle is 360 degrees, then I have a full circle which is formed. And hence this angle which is one full 360 degrees is called one full circle angle. X is called one full circle angle. Is how we derive the different types of angles connected with lines and angles. Types of angles in special cases. Complementary angles is what we are going to discuss in the session. What are complementary angles? Now that we have discussed about the different types of angles, now let's enter into understanding the types of angles extended with the definition complementary angles. What are complementary angles? The angles whose sum is 90 degrees is called complementary angles. That is, when I take the angles x and y, if x plus y equals 90 degrees, then we say the angles x and y are complementary angles. Let's see the definition more briefly. Imagine I have two lines which are perpendicular to each other. There are two lines out here which are perpendicular to each other. Imagine there's an angle between them. There's another line which makes an angle x and y with the given perpendicular lines. Now, since we know that the whole line is perpendicular, therefore, by each angle being x and y, the sum would be 90. Therefore, clearly I can see from this diagram that angle x plus angle y equals 90 degrees. And when sum of two angles is 90, then we call x and y to be complementary angles. Two angles are said to be complementary if the sum of those two angles is equal to right angle, which is 90 degrees, as can be seen with this example problem. Complementary angles. Now next is about supplementary angles. Let's see what do we mean by supplementary angles. As with the similar definition of complementary angles, now comes defining the supplementary angles. Supplementary angles. If the sum of two angles is 180 degrees, then we say the two angles are supplementary angles. So let's see the definition more briefly. Imagine I take a straight line. Let me say there's another line which cuts this line at some angle. Therefore, I have this line which cuts these two angles, say with angle X, and this is angle Y. Now clearly when I see this part being angle X and this part being angle Y, clearly angle X is acute and angle Y is obtuse, because this is less than 90 and this is more than 90. As can be seen with an imaginary perpendicular line, this will be more than 90, less than 90. X is acute, Y is obtuse. Also, when I observe this, I know that angle in a straight line is always 180 degrees, is what we know as the property. So since the angle in a straight line is 180, this whole angle must be 180 degrees. And also when I connect this with this X and Y, I see that angle X plus angle Y makes the whole angle of the straight line. Therefore, as seen from the diagram, X plus Y is 180, and we have the property that if the sum of the angles is equal to 180 degrees, then the two angles are called supplementary angles. If this equals this, implies X and Y are called supplementary angles. Supplementary angles and its definition. So the learning outcome is, if the sum of the angles is 90, the two angles are called complementary angles. If the sum of two angles is 180 degrees, then the two angles are called supplementary angles. Complementary and supplementary angles. Now that we have discussed about supplementary and complementary, it is also very important that we also know some basic angle rules in lines and angles. So let's see some basic rules in angles, how we define the different types of angles existing in geometry. For example, initially I have adjacent angles. What are adjacent angles? The word adjacent means the one besides the other. Therefore, when we take two angles, the rule is that the two angles are said to be adjacent when one is exactly besides the other. For example, let's take an example case. For example, I have two lines out here, where this angle is X and this angle is Y, and this angle is Z, X, Y, Z. Now here, let's see how the adjacent angles can be applied to this. Now clearly I see that X and Y are besides each other. But when I take the pairs X and Z, they are not besides each other. So very clearly I can say X and Y are adjacent angles. Y and Z also are adjacent because they are besides each other, are also adjacent angles. But when I take this angle X and this angle Z, they are not adjacent because clearly they are separated by the angle Y, as can be seen. Therefore, but X and Z are not adjacent angles because they are not side by side is the rule I identify in adjacent angles. Two angles are adjacent if they are besides or side by side. XY adjacent, YZ adjacent, XZ not adjacent is how I understand the adjacent angles in the geometry of the planes. Next is about linear pair of angles. Let's see what are linear pair of angles. As clearly the word itself says, linear pair, what do we mean by linear pair? That means the angles involved in a straight line. The pair of angles involved in a straight line. Linear pair indicates pair of angles involved in a straight line. Let's see how the pair of angles are involved in a straight line. In order for that, I need a straight line. So let's draw a straight line and see. I have a straight line out here represented by L. Then I have another line or a ray which makes an angle. When it intersects the straight line out here, intersects the straight line L out here, it makes two angles, X and Y. So in such case, we clearly see this pair of X and Y to be the linear pair because these two angles together make a straight line. That means for the pair of angles to be linear pair, the sum must be 180, or the sum must be, or the angles must be supplementary angles as learnt in the previous case. Therefore, clearly I see here that X and Y are pair of angles involved in a straight line. Or pair of angles involved in a straight line. Also, if you notice here, we observe that X plus Y equals 180, as can be seen in the linear pair, since L is a straight line. Therefore, I can say X and Y are supplementary or supplementary angles. Therefore, we have X and Y are said to be linear pair if XY are supplementary, is how I make the learning outcome. The condition that X and Y are linear pair of angles is that X and Y must be supplementary. That is, X plus Y must be equal to 180, or it must be in a straight line. This is how we understand the linear pair or supplementary in a straight line. They cannot be supplementary outside the straight line, but on a straight line they must be supplementary, and hence for linear pair they must be on a straight line. X and Y are linear pair of angles when they are involved in a straight line. Angle X and angle Y is how we understand. Now the next type of angles which we're going to discuss in the plane geometry is vertically opposite angles. Let's see what are vertically opposite angles. vertically opposite angles. Let's see the definition through the diagram. Imagine I have two lines which are intersecting in the plane. Say for example, my line L1 and my line L2 intersect at this point. Now let's see how we can define the vertically opposite angles for the case of two lines L1 and L2 intersecting at certain point. So in this, as we know that opposite angles, vertically opposite in the sense, there are two angles which are opposite out here, this and this, and these two are called vertically opposite angles. Or I take this 1 and 2 and I take here 3 and 4. As can be seen here, these two are vertically opposite angles 1 and 2, and 3 and 4 are the next pair of vertically opposite angles. So here in this diagram we have angle 1 and angle 2 are said to be vertically opposite angles. Similarly, angle 3 and angle 4 are also said to be vertically opposite angles. 1 and 2 and 3 and 4 are said to be vertically opposite angles. So when two lines intersect, at that point of intersection we have four angles formed, and the opposite pairs are said to be vertically opposite angles. In this case, 1 and 2, 3 and 4 are vertically opposite angles. Also, geometrically, we have angle 1 equals angle 2 and angle 3 equals angle 4. So vertically opposite angles are always equal in point of intersection. So here we make a property that vertically opposite angles are always equal. For any lines intersecting, this is universally true. It's said to be universally true. Is how we understand the vertically opposite angles are always equal for any two lines intersecting. Angle 1 equals angle 2, angle 3 equals angle 4. Is how we understand the learning outcome and the definition of vertically opposite angles. Now next, let's see, now that we have discussed about the different types of angles defined in the lines, now let's enter into taking the condition of the possible lines, two lines, whether they intersect or do not intersect, are they parallel, are they coincident, etc. So let's see different cases of two lines intersecting or non-intersecting. So here I have types of lines. So when I take two lines, there are different possible ways in which I can understand the geometry of the lines. Initially, let me come with the first case. When I have two lines, the possibility is that this line L1 and this line L2 intersect at a point P. This is the first case where the two lines intersect at the point P. When I take the second case, there is the possibility that the two lines are parallel to each other. So there is a possibility that the two lines either cross each other or do not cross but exactly go on a railway track, never meet each other. So we have the second case, which is of this form. The third case is when the two lines L1 and L2, the line L1 and L2 lie on each other. They overlap, or one line lies on the other, or they are coincident. So let's see the three cases where the lines intersect at a point or parallel to each other, they are coincident. So here such lines are called intersecting lines. In such a case, these kind of lines are called intersecting lines, and when they are going exactly at equal distances on the railway track, then we say such lines are parallel lines. And in this case, when the two lines exactly overlap on each other, making us look like as if there is only one line, but L1 and L2 are exactly on each other, then in that case, these kind of lines are called coincident lines. Is how we understand the different types of lines existing in the plane geometry. Intersecting lines, parallel lines, coincident lines. Now that we have discussed about the different types of angles and the different types of pairs of lines existing and various other properties connected with lines and angles, now let's see one of the axioms which is important in understanding the lines and angles more better. An axiom with its own definition. Now here an axiom says, if a ray stands on a line, then the sum of two adjacent angles so formed by the ray with that of the straight line is 180 degrees, is how the property or the axiom says. So let's see this axiom through the diagrammatic representation to understand the concept more easier. So here it says, if a ray stands on a line, so let me take a straight line. Here is the straight line, say L. And imagine I project a light through the torch on this. So a ray of light is made to hit out here. If a ray stands on a line L, this is how it stands in any angle irrespective of 90 degrees. Then if a ray stands on a line, this being the ray, this being the line, the axiom says that the sum of two adjacent angles so formed by the ray, we clearly know that the adjacent angles formed by the ray are this and this. So the sum of two adjacent angles so formed by the ray with that of the straight line will always be 180. So these two adjacent angles always form the sum 180. Obviously, because the ray makes with the straight line being 180, the property says x plus y is this. This is how the axiom states. If a ray stands on a straight line, then the sum of the angles, adjacent angles so formed by the ray with that of the straight line will always be 180 degrees. That is, x and y will be supplementary angles, is how we understand the axiom related with plane geometry. Now that we have discussed about axiom 1, let's see the axiom 2, which relates to the properties of the plane geometry. Axiom 2 and its definition. Axiom 2 states that if the sum of two adjacent angles as made by the ray is 180 degrees, then the two non-common arms which make the respective adjacent angles with the ray must form a line, is how the property says. Let's see axiom number 2. The axiom clearly states if the sum of two adjacent angles as made by the ray. Now it is given that the angles are adjacent. Say for example, I have a ray. Now this ray makes adjacent angles and the sum of adjacent angles is 180 degrees, and then the two non-common arms which make the respective adjacent angles. Say for example, my adjacent angles here are x and y. They are besides each other. Then the angle x which the ray makes, say this is the angle x as made by the first non-common arm. This is the first non-common arm which makes an angle x with this ray. Now there's another angle y which is just adjacent to x and made by the other non-common arm. So let's see the other angle which is made by angle y. So the ray makes an angle y with the next second non-common arm. So the first non-common arm makes an angle x with the ray, and the second non-common arm makes an angle y with the ray. Now the axiom 2 states that in such a case where x and y are adjacent, these two non-common arms must form a straight line. They cannot be bent, they must be straight, or they form a straight line, is how the property states, the axiom number 2. Therefore, first and second non-common arms must form a straight line according to axiom number 2. Therefore, when x and y are adjacent angles as made by the ray with the two non-common arms, first and second, then this ray making an angle x with the first non-common arm and this ray making an angle y with the second non-common arm, and provided x and y are adjacent besides each other, then the axiom number 2 states that the first and second non-common arms must be a straight line. They cannot bend even with a slight angle. They must be forming a straight line. Axiom number 2 and its definition. And as the two axioms which we have discussed in the session, axiom number 1 and axiom number 2 are very much related to the linear pairs. Therefore, the two axioms related to the linear pairs are called linear pair axioms. Just to make a note, the two axioms which we have discussed are called linear pair axioms. That's how we define the axioms and the respective linear properties. Now let's see the property of vertically opposite angles. Now that we have discussed with the axioms on linear pair of angles, let's see a property related to the vertically opposite angles. As we have clearly seen, let's see a theorem which relates to vertically opposite angles. Vertically opposite angles are derived when two lines intersect. So here is line 1 and here is line 2 intersecting at this point. Then we know clearly that pair 1 and 2 are called vertically opposite and pair 3 and 4 are called the other set of vertically opposite angles. Now this theorem says that the vertically opposite angles are always equal, is how the theorem states. Vertically opposite angles are always equal. Let's see how we can come to the conclusion that vertically opposite angles are always equal. Let's come with the first case, where if I take this line L1, I clearly see that 1 and 4 are adjacent angles. In line L1, I clearly see angle 1 and angle 4 are adjacent or besides each other. Not only that they are adjacent, but they form a linear pair. Also, one and 4 form a linear pair. They form a linear pair, and therefore 1 plus 4 must be equal to 180 degrees. That implies angle 1 plus angle 4 equals 180 degrees is how I get the linear property. Similarly, if I take the line L2, in line L2, angle 3 and angle 4 are clearly, angle 2 and angle 3 are adjacent angles. And as you see, angle 2 and angle 3, they also form a linear pair. Also, angle 2, angle 3 form a linear pair. And therefore, because these two form a linear pair, the sum of angle 2 plus angle 3 must be equal to 180. as the second case. Is how we get the linear property. Now, as we see with the first property, angle 1 plus angle 4 is equal to 180. Similarly, when I take angle 1 and 3 from the above diagram, I clearly see that angle 1 plus angle 3 is also equal to 180 degrees, and angle 2 plus angle 4 is also equal to 180 degrees. Because it's a straight line out here and this is a straight line out here. 1 plus 3 is 180, 2 plus 4 is also 180. So here I have four equations: equation 1, equation 2, equation 3 and equation 4. So let's see how we can prove. As I see that equation from 1 and 3, I clearly see that the two equations are same, because the right hand side is 180 and the right hand side is 180. By trans 2 property, both the left hand sides must be equal. Therefore, from equation 1 and 3, I observe that angle 1 plus angle 4 is equal to angle 1 plus angle 3, because the right hand sides are equal. Therefore, from equation 1, angle 1 plus angle 4 must be equal to angle 1 plus angle 3. Therefore, the two angles being equal can be cancelled on both sides. Therefore, I get angle 4 equals angle 3. Is one property which I have proved. Similarly, let me take equation 2 and equation 4 and see what we can conclude. Now, from 2 and 4, also equally I can conclude that from equation 2, angle 2 plus 3 is 180, and from 4, 2 plus 4 is 180. Because the right hand sides are equal, the left hand sides must be equal. Therefore, this on the left hand side must be equal to this on the left hand side. So here, angle 2 plus angle 3 is equal to angle 2 plus angle 4, where the two angles being equal will be cancelled on both sides. Therefore, I get my angle 3 equals angle 4. Of course, here I get the same thing because they are same. So I have my angles here. One of the pair vertically opposite are equal. Therefore, vertically opposite angles, angle 3 and angle 4 are equal. Vertically opposite angles, angle 3 and angle 4 are equal. Is how we conclude the vertically opposite angles. 3 and 4 are equal. What about 1 and 2? Yes, they are, because when angle 3 is equal to angle 4, then angle 1 is 180 minus angle 3 and angle 2 is 180 minus angle 4, where we can prove that angle 1 and angle 2 are also equal. Let's see how we can show the other pair being equal from this. Continued. Now let's see how we can prove angle 1 equals angle 2. So as can be seen that we have proved angle 3 is equal to angle 4. Which is already proved. Now using this, let's see, angle 3 can be written as 180 minus angle 1, because the whole of 180 degrees minus angle 1 gives me angle 3. Therefore, angle 3 can be written as 180 minus angle 1, and similarly my angle 4 can be written as 180 minus angle 2. Therefore, this comes out to be 180 minus angle 2. The two 180 degrees being equal can be cancelled, and therefore minus angle 1 equals minus angle 2, and finally I get this to be angle 1 equals angle 2. Is how I conclude angle 3 equals angle 4 and angle 1 equals angle 2. Therefore, vertically opposite angles are always equal. Is how we conclude the property. Vertically opposite angles are always equal. It's universally true, as proved mathematically out here. Property and its theorem. Now that we have discussed the various properties, theorems and axioms related to linear pair and vertical pair, vertically opposite angles, let's see some applications of the properties in real life. Applications of linear pair and vertically opposite angles. Applications of linear pair and vertically opposite angles is the topic of the session. So let's see some applications related to the theorems and axioms as learnt in the previous sessions, related to linear pair, adjacent pair and vertically opposite angles. Imagine I have a problem which says ABC is a triangle. Say for example, I have a line L which intersects another line L2, and there is a ray passing by out here. Now here I have this to be (40 degrees), and then this is given to be 30 degrees. So here I have a problem which says this angle is 40 degrees and this is 30 degrees, and I need to find this angle, and also I need to find this angle and this angle. So here is a question which relates to linear pair and vertically opposite angle properties. So let's see how we can find each of these angles using the condition of 30 degrees and 40 degrees. So let's see how we can find this. As we can clearly see that this is equal to this, as they are vertically opposite angles. If I take the line L1 and L2 irrespective of the ray, I clearly see that this being 40 degrees must also be equal to this angle, which is 40 degrees. Therefore, this angle must be 40 degrees, because since they are vertically opposite angles, and vertically opposite angles are always equal in the pair of lines intersecting. So this equals this being 40. Now let's come to this angle. Now we know that L2 is a straight line, and therefore in a straight line, this angle plus this angle plus this angle, each of the angles must be equal to 180. Sum of each of the angles must be equal to 180. So angle this plus angle this plus angle this must be equal to 180. As we can see, if I take the line L2, which is a straight line, I see that this is the angle made by L1, which is 40 degrees, and this is the angle made by the ray, which is 30. But this is 30 degrees, and the remaining angle is what we need to find. So this being a straight line, the sum of each angle, sum of all three angles must be 180. Therefore, this angle will be 180 minus 30 plus 40, because the whole of 180 minus this gives me the required angle, which on further simplification gives 180 minus 30 plus 40, which is 70, where 70 when subtracted from 180 is 110. Therefore, if I take this as x, this as y, and this is z, my angle y would be equal to this. Angle y equals 110 degrees. Now that I have found each of the angles, now the question comes on how to find z. So let's see how we can find angle z, continued from angle x and angle y. To find angle z, now clearly, as I see, the sum of all the angles taken here must be equal to the circle angle, that is 360, because this angle x plus 30 degrees plus this plus this plus this forms one full circle, in which angle in one full circle is 360 degrees. Therefore, I get the circle property coming into existence here. That is, from the diagram, this, I clearly see that 40 degrees plus 30 degrees plus 110 degrees plus 40 degrees plus z must be equal to 360 degrees, is how we get from the circle property by circle angle, or since this is a circle angle, it must be equal to 360 degrees. When I add this, 40 plus 30 is 70, and 70 plus 40 is 110, which is 220, plus z equals 360 degrees, which on further simplification gives, that implies z is 360 minus 220, that implies my z is 140 out here. So my angle z is equal to 140 degrees. Using the circle angle, I can find each of the angles, angle x, angle y, and angle z, with their own respective approach. Given the angles, we can find the adjacent or the vertically opposite angles using the properties as learnt in the previous session. Real life applications of linear paired and vertically opposite angles. Transversal. The next topic in the session is about discussion of transversal. What is transversal? Let's see the definition and its property in more brief in the session. transversal. What is transversal? As we see, imagine I have two lines L1 and a line L2. Any line which intersects L1 and L2 at two distinct points is called transversal. Say for example, I take a line which cuts the line L1 at P and the line L2 at Q, then this line is called the transversal. Transversal is a line which cuts two or more than two lines at two distinct points P and Q. This is the transversal for these two lines, is how we understand the transversal. Imagine I have L1, L2, L3, L4, L5 and L6. There are 6 lines out here, and then there's a line which cuts this at A1, A2 and cuts L3 at A3 and cuts L4 at A4, L5 at A5. Then this line which cuts each of the lines L1, L2, L3 etc. till L6 at different 6 distinct points A1, A2, A3, A4, A5 and A6 also is called a transversal. A transversal does not have a restriction on two lines, but there can be any number of lines through which the line must cut at distinct points. So this is also an example of a transversal, as how we understand the transversal property of the condition. Is how we understand this. Imagine I have a line L1 and line L2, and here I have a line which cuts L1 at P but does not cut the other line. Therefore, this cannot be a transversal for L1 and L2. Is not a transversal for L1 and L2, is how we understand the transversal property in mathematical understanding. Transversal is a line which cuts more than two lines at two distinct points or at all distinct points, is how we understand transversal in geometry. Parallel lines. As we have discussed about parallel lines in many instances while coming across in theorems, axioms, solving problems, let's see in brief about what are parallel lines and what are the mathematical properties related with parallel lines. Parallel lines and its discussion. What are parallel lines? Imagine we have a railway track in which the two rails are exactly at equal distances. There is no possibility that the two rails meet at the railway track. So the railway track can be taken as an example of parallel lines, which are separated by this grids out here. The two rails, this is rail 1 and this is rail 2, and the two rails never meet, but they go on and on and on, but they never try to meet, is how we understand the two parallel lines. So mathematically, when I connect these two rails with the railway track, I clearly understand that this is an example of lines which are parallel. Since these two never meet, they are parallel. So mathematically, I define the parallel lines to be those lines which never meet. They always go on and on till infinity, but they never meet, is how we understand the parallel lines. Parallel lines and its properties to be continued further. Now let's take two parallel lines to understand the further properties related. Imagine I have two parallel lines, L1 and L2. So these two lines are parallel because they go on and on, but they never meet. And interestingly, there will be equal distance at every pair taken on the two lines. They are at equal distances everywhere. And let me say there's a transversal which cuts the lines L1 and L2 at these two distinct points. These 2 points of intersections. Now, as we can see that the transversal, when it cuts both L1 and L2, makes 4 angles with L1. 1, 2, 3, 4. This transversal, when it cuts line L1, makes 4 angles, 1, 2, 3, 4 with this, and makes the other 4 angles with the line L2 out here. So totally there are 8 angles formed by the two lines which the transversal cuts with, is how we connect the properties. A transversal cutting the lines L1 and L2 which are parallel. L1, L2 are parallel as they never meet. Because they never meet, they are parallel. And let's see how are the properties related with the parallel lines with the transversal. So let's see the interior angles in the parallel lines. To start with, the first property related with interior angles. So parallel lines connected with interior angles. Is what we are going to discuss in the session. So let me take two parallel lines. L1 and L2. And let me have a transversal which cuts the lines L1 and L2, thus making 4 angles here. 1, 2, 3, 4, 5, 6, 7, 8. Now, out of these 8 angles, we call the interior angles as those angles which are in the interior region of the parallel lines. So clearly I can see that this and this are in the interior region of the parallel lines, where 1, 2, 7 and 8 are said to be outside, that is in the exterior region. So interior angles are the angles in the interior region. So let's see what are the angles in the interior region. Angle 3, angle 4, angle 5, angle 6 are said to be the angles in the interior region, and therefore these angles which are in the interior region of the parallel lines are said to be interior angles. Interior angles in the parallel lines is angle 3, angle 4, angle 5 and angle 6. Now let's see the exterior angles. Now that we have discussed about interior angles being the angles in the interior region of the parallel lines, exterior angles is the pair of angles which are in the exterior region of the parallel lines. It's very simple, as similar as the interior angles. So let's see exterior angles in the pair of parallel lines through the transversal. Exterior angles. Let me take the pair of parallel lines L1 and L2 with the transversal cutting the lines L1 and L2. And making 8 different angles with L1 and L2. Now clearly when we see in this, we see that angle 1, angle 2 are the exterior of a line L1, and angle 8 and angle 7 are in the exterior region of the line L2, wherein this is in the interior region of the parallel lines. So this 2 and this 2 being on the exterior region are called the exterior angles. To be followed with exterior angles are defined to be angles in the exterior region of the parallel lines. So here the exterior angles are angle 1, angle 2, angle 7 and angle 8. So here these 4 angles being on the exterior region are called exterior angles. Exterior angles in the pair of parallel lines. Angle 1, angle 2, angle 7 and angle 8. Now that we have discussed about interior and exterior angles in the pair of parallel lines, now comes the corresponding angles. So let's see what are corresponding angles in the pair of parallel lines. Corresponding angles in the pair. So let's take one pair of parallel lines L1 and L2. Let there be a transversal which cuts the 2 lines. Now for this transversal, as we already discussed about 8 angles which are formed with L1 and L2, we have 1, 2, 3 and 4, 5, 6, 7 and 8. Then the corresponding angles are said to be the angles which are correspondingly above lines L1 and L2. So if I have this angle 1, my corresponding angle with 1 is said to be angle 5. And corresponding to angle 2, we call 6 to be corresponding. Corresponding to 3, that is an angle which is below L1 is corresponding to the angle which is exactly below L2. So this is corresponding to this. An angle which is below L1, which is 4, corresponds to an angle which is below L1 corresponding exactly in the same region. So these are called corresponding angles in the pair of parallel lines. Corresponding angles are the angles which correspond to the same region. So angles which correspond to the same region are corresponding angles. In this case, angle 1, and interestingly, in parallel lines, the corresponding angles are equal only when the lines L1 and L2 are parallel. Therefore, angle 1 equals angle phi, which are corresponding, and angle 2, which is out here, is equal to angle 6, and angle 4, which corresponds to angle 8, are equal, and angle 3, which corresponds to angle 7, are said to be corresponding angles and are always equal. Therefore, I have a property which says L1 parallel to L2 is the symbol for parallelity. So when line L1 is parallel to L2, implies corresponding angles are equal always. Or always equal. So L1 parallel to L2 implies corresponding angles are always equal when lines L1 and L2 are parallel. Corresponding angles connected. Now that we have discussed about corresponding angles and all the corresponding pairs being equal in parallel lines L1 and L2, next comes the property of alternate angles. So let's see what are alternate angles in the parallel lines. Alternate angles. Imagine I have two parallel lines L1 and L2 divided by a transversal. Then we know that there are 8 angles which are formed with L1 and L2, which is 1, 2, 3, 4, 5, 6, 7 and 8. Now here we call the alternate angles which are on the vertically opposite side. So they are on the vertically opposite side, and this is vertically opposite to this. No, this is vertically opposite. So we have alternate angles which are alternate to the transversal. So clearly I see that this is alternate to this and this is alternate to this. So 3 and 5 are alternate, 4 and 6 are alternate to each other. So I have alternate angles to be angles which are alternatively in the region of either side of transversal is what we define as alternate angles. So have this angle 3 and angle 5 are alternate angles and therefore they are equal in parallel lines. The parallel line property says that alternate angles are always equal in case of two lines L1 and L2 being parallel. Therefore, angle 3 is phi, angle 4 is equal to angle 6, and these 4 angles are called alternate angles. And mathematically, we have the property which says L1 parallel to L2 implies alternate angles are always equal, is how we have the property which says alternate angles are always equal in case of two lines L1 parallel to L2. Alternate angles 3 and 5, 4 and 6 in the pair are equal in parallel lines. Now next is the discussion of vertically opposite angles when two lines L1 and L2 are parallel cut by the transversal. Vertically opposite angles in pair of parallel lines. Vertically opposite angles. Let's see what are vertically opposite angles. Imagine I have two parallel lines L1 and L2. Line L1 and line L2 cut by a transversal. Now we know that there are 8 angles as made by the lines with the transversal. Now vertically opposite are the one which are vertically opposite each other, as we have already discussed about vertically opposite angles. These two are opposite and these two are opposite. Therefore, in case of this vertically opposite angles which are opposite to each other, as can be seen, one is vertically opposite to 3 and they are always equal, as proved in the previous theorem. Vertically opposite angles are always equal. So 1 equals 3 and 2 equals 4. Similarly, 5 and 7 and 6 and 8 are all the possible pairs which are equal in parallel lines. These are vertically opposite angles. Therefore, when the lines L1 and L2 are parallel, their vertically opposite angles are also universally equal. Corresponding angles, alternate angles, and vertically opposite angles are always equal in case of two lines being parallel. Interior and exterior angles connected with parallel lines. Now that we have discussed various properties connected with two parallel lines and the transversal, now comes the most important property called interior angles on the same side of transversal. Let's see how this plays a vital role. Interior angles on the same side of transversal. On the same side of transversal. So imagine I have two lines L1 and L2 which are parallel to each other. I have a transversal which makes 4 angles with L1 and L2. Angle 1, 2, 3, 4, 5, 6, 7 and 8. Now, when we discuss about interior angles on the same side of transversal, we have already discussed about Totally, there are 4 interior angles in this, that is angle 4, angle 3, angle 6 and angle 5, which are interior angles. Now out of this, we clearly see that these two are interior angles on the same side of transversal, and these two are the interior angles on the other side of the transversal. Therefore, as seen from the diagram, angle 4 and angle 5 are said to be interior angles on the same side of transversal. Similarly, angle 3 and angle 6 are the interior angles on the other side of the transversal, of course on the same side. Also, angle 3 and angle 6 are interior angles on the same side of transversal, is how we understand the interior angles connected with the parallel lines L1 and L2. Interior angles on the same side of transversal. Also, the interior angles on the same side of transversal are also referred with the names allied angles, or they also referred to be co-interior angles. So there are different names out here, and the interior angles on the same side of transversal are sometimes referred as allied angles or co-interior angles, or they are also referred as consecutive angles, which are the different names as given for interior angles on the same side of transversal. Consecutive interior angles is how we give the different names for the interior angles on the same side of transversal, which are also called allied angles or co-interior angles or consecutive interior angles, is how we understand the interior angles on the same side of transversal connected with the parallel lines. Now that we have discussed about interior and exterior angles, and most importantly in the previous session where interior angles on the same side of transversal or the allied angles which we have discussed, let's see the mathematical property which connects interior angles on the same side of transversal connecting with supplementary angles. Interior angles versus supplementary angles. Let's see how the interior angles are connected with the supplementary property. So let's take two parallel lines L1 and L2. Here is line L1 and here is line L2, which are parallel to each other. Now with these two lines being parallel, let's take a transversal out here. Now with this transversal, we know that there are 8 angles formed, with 4 angles formed with L1 and 4 angles formed with L2, is how we connect the 8 angles which the transversal forms with L1 and L2. Now we know that the interior angles on the same side of transversal are 4 and 5 and 3 and 6. So angle 4 and 5 and angle 3 and angle 6 are the interior angles on the same side of transversal. Now the property says that in mathematics, the pairs angle 4 plus angle 5 is always 180. This plus this is 180 and this plus this also is 180. Is how we see the properties. Interior angles on the same side of transversal are supplementary. The sum is 180. Therefore, angle 4 and angle 5 are supplementary angles. Angle 3 and angle 6 are also supplementary angles. Is how we understand the pairs being supplementary angles. Interior angles on the same side of transversal are equal to 180. That is, they are supplementary angles. Now that we have discussed about various properties connected with parallel lines, now let's see the reverse process of understanding the same properties. Parallel lines connected with reverse process. So what is this reverse process? Say for example, we have discussed in the previous session that when two lines are parallel, their corresponding angles are equal. Now my question is, if the corresponding angles are equal, will the lines be parallel? So we are investigating now in the reverse process. Imagine I take two lines which are not parallel. Say I take two lines somewhere in this manner, and I just take a transversal out here. Then we know that there are 8 angles formed, 4 with L1 and 4 with L2. Now, when I say that the corresponding angles are equal, let's see if the lines are parallel. So as we know that the corresponding angles are same, that means angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8 must be same. So let's draw two lines randomly with the transversal and measure each of the angle, 1 with 5, 2 with 6, 3 with 7 and 4 with 8. So when we measure the angle 1 with the protractor, we should also equally measure the angle 5 with the protractor out here. Then let's see if the angles are equal. If the angles are not equal, then we can say that if the lines are not parallel, their corresponding angles are not equal. If the corresponding angles are equal, then let's take the case where the corresponding angles are equal. So here 1, 2, 3 and 4, 5, 6, 7 and 8. So let's take the case where the corresponding angles are equal. Then the property says that if the corresponding angles are equal, then the lines which follow that angle and the transversal must be parallel. If the lines are not parallel, then we cannot have the possibility that the corresponding angles are equal. Therefore, if the corresponding angles are equal, then the lines L1 and L2 must be parallel. This is how the property comes as converse of the lines L1 and L2 are parallel, the corresponding angles are equal. If the corresponding angles are equal, the lines L1 and L2 must be parallel. This is how the reverse process of understanding corresponding angles connected with parallel lines. Now let's see the reverse process connecting the alternate angles. As we know that when two lines L1 and L2 are parallel, their alternate angles are equal. Therefore, now let's investigate if the alternate angles are equal, will the lines be parallel? Reverse process of parallel lines, reverse process connected with alternate angles. Alternate angles. The lines L1 and L2 which are not parallel divided by the transversal and having the angles out here, we know that the alternate angles are 4 and 6. If angle 4 equals angle 6 and angle 3 equals angle 5, that is, if alternate angles are equal, then the property says that with the alternate angles being equal, the lines must be parallel. There is no other possibility but the lines L1 and L2 must be parallel. If alternate angles are equal, then the lines L1 and L2 must be parallel. That is, L1 parallel to L2 is how we understand the reverse process. If the lines L1 and L2 are parallel, alternate angles are equal. But if the alternate angles are equal, then the lines L1 and L2 also must be parallel. The reverse process of understanding alternate angles connected with parallel lines. Now let's see the reverse process of connecting interior angles with the parallel lines. Parallel lines in reverse process connected with interior angles, or in this case more specifically called allied angles, on the same side of transversal being called allied angles. As we have seen in the previous properties that if x and y are allied angles in the parallel lines L1 and L2, then x and y are supplementary angles. That is, x plus y must be 180 if x and y are allied angles, because they are interior opposite angles or interior angles on the same side of transversal. Now comes the question of reverse process. If the interior angles sum up to supplementary or sum up to 180, will the lines L1 and L2 be parallel? This is the biggest question out here. So let's investigate on interior angles connected with parallelity. Let's take two lines L1 and L2. These two are the lines L1 and L2 divided by a transversal. It makes four angles: 1, 2, 3, 4, 5, 6, 7, 8. is how I get 8 different angles. Now we know that angle 4 and 5 are interior angles on the same side of transversal. Angle 4 and angle 5 and angle 3 and angle 6 are interior angles on same side of transversal. So let's see with the property that if angle 4 and angle 5 are supplementary and angle 3 and angle 6 are supplementary, then the reverse process says that given the condition that interior angles on the same side of transversal are supplementary or the sum is 180, then L1 must be parallel to L2 is how the condition states in parallelity. So the reverse process holds for corresponding angles, alternate angles and interior angles on the same side of transversal, that is for allied angles, is how we understand the reverse process being true for all the 3 connected angles for the parallel lines L1 and L2. Now that we have discussed about the parallel lines and the transversal which make various properties in mathematics, the alternate angles, the corresponding angles, the interior angles, the exterior angles and vertically opposite angles. Let's take the topic connected to the parallel lines. Parallel lines connected to the same line. So here today's session is about the lines which are parallel to the same line. Today's session is about the property which relates to the lines which are parallel to the same common line. Let's see how the 2 lines are connected if they are parallel to the same line. So imagine I have the common line, say line L. If there are 2 lines which are parallel to L, say for example there is a line L1 which is parallel to L, and say there's another line L2 which is also parallel to L. So here my condition is let L be the line. Now let L1 be parallel to L and there exists another line L2 which is also equally parallel to L. Now the relation between the lines L1 being parallel to L and L2 being parallel to L makes us the mathematical property with the common line L that the other 2 lines must be parallel. If there are 2 lines such that they are parallel to the common line L, then obviously the 2 lines also must be parallel to each other, is how we understand the property connected with lines parallel to the same line. Therefore, if there are 2 lines which are parallel, that implies L1 must be parallel to each other, is how we connect the property related to the parallel lines in common line L. So here we have 2 lines which are parallel to the same line are parallel to each other is how we understand the property connecting two lines which are parallel to the same line or parallel to each other. The lines L1 and L2 which are parallel to line L are in turn parallel to each other is how the property connects with lines parallel to the same line L. Mathematically true for all lines in such situations. Now that we have discussed all the properties of parallel lines geometrically connected in a plane, let's see the applications of parallel lines in real life. The topic of the session is applications of parallel lines in real life. Applications of parallel lines. So let's see the different applications of parallel lines in real life. Imagine I have the condition of two parallel lines with certain angles given. I can find certain unknown angles using the properties as we have learned in the previous sessions connecting two parallel lines and transversal. So let's see how we can use the learned properties into the session as an example real life problem. For example, I have the question which says find the remaining angles for the following diagram. So in this case, I have two lines. Say there are two lines L1 and L2 which are parallel to each other. And say I have a transversal which is given in the problem. Now with the given lines L1 and L2 and the transversal which cuts the lines L1 and L2 at two distinct points out here and out here, let me say I have an angle out here which is given to be 110. Now my question is find the remaining angles for the following diagram. So given that this is 110, I need to find this angle, this angle, this angle, this, and this using the 110 degrees. So let's see how we can find each of the angles, this, and this using 110 degrees which is given out here. So let's see each of the angles. As we know that the angles are represented by angle 1, angle 2, angle 3, angle 4, 5, 6, 7 and 8. So let's represent each of the angles by 1, 2, 3, 4, 5, 6, 7, 8. And let's find each of the angles, angle 2, angle 3, 4, etc. till angle 8 using the first angle which is given to be 110 degrees. So here it is given angle 1 is equal to 110 degrees. Clearly angle 1 is given to be 110 degrees. Given that angle 1 is 110 degrees, let's find first angle 2. So initially to find angle 2. So we know that clearly angle 1 plus angle 2 is 180 degrees because this makes a straight line. Therefore, angle 1 plus angle 2 makes a straight line that is 180 degrees. Therefore, this plus this is 180. That implies angle 1 which is 110 degrees is substituted for angle 1 out here plus angle 2 which I need to find using this equation. Therefore, when I find angle 2, this is 180 minus 110, which on further simplification gives angle 2, which is 70 degrees. Therefore, my angle 2 utilizing angle 1, which is given to be 110 degrees, is used with straight line property, and I get angle 2, which is 70 degrees. Is how I get this angle to be 70 degrees. Now let's find angle 3. Let's see how we can find the next coming angle, that is angle 3 out here. To find angle 3, so here, to find angle 3, so to find angle 3, clearly I see angle 1 and angle 3 to be vertically opposite angles. Therefore, from the diagram I see that angle 1 equals angle 3, since they are vertically opposite angles. They are vertically opposite angles, and hence they must be equal, is what we have seen as the property in the previous session. Vertically opposite angles are always equal. Therefore, angle 1 equals angle 3. But we know that angle 1 is 110 degrees, as clearly given in the condition with the given problem. Angle 1 is 110 equals angle 3. Therefore, I clearly have my angle 3, which is equal to 110 degrees. So my angle 3 is now 110 degrees. Now comes finding angle 4. Let's see how we can find angle 4 using the basic angle 1 equals 110 degrees. Next, to find angle 4. As we can clearly see, just like in the previous session, that angle 1 and angle 3 are vertically opposite angles, similarly angle 2 and angle 4 are also vertically opposite angles. Therefore, I have angle 2 equals angle 4, since they are vertically opposite to each other. Vertically opposite angles, and vertically opposite angles are always equal. Therefore, let's see what is angle 2, which we have already found in the previous case. We have found angle 2 to be 70 degrees, which I'm going to substitute in place of this, which I get through angle 4. Therefore, this being 70 degrees, indirectly I get my angle 4, which equals 70 degrees. That's how I understand the concept of finding angle 4. So my angle 4 out here is 70 degrees. So each of the angle in the first part of the line L1 and the transversal are now found out. Angle 1 given as 110 degrees, angle 2 which is found to be 70 degrees, angle 3 which is found to be 110 degrees, and angle 4 which is found to be 70 degrees is how we find all the 4 angles of the line L1 with the transversal. Now comes the next question on how to find angle 5, 6, 7 and 8, the angles made by the line L2 with the transversal, is what is the next investigation to be continued with. Now that we have found these 4 angles, let's see how we can connect this set of the 4 angles with this set of the 4 angles. So let's start with initially angle 4. As clearly we found angle 1 which is 110 degrees, now the question comes on finding angle 5. So let's see how we can find the next consecutive angle, angle phi. Now clearly I see that angle 1 and angle phi are corresponding angles, and hence 1 and phi must be equal, because corresponding angles are equal when two lines are parallel. I have my angle 1 which is equal to angle phi because they are corresponding angles. Since corresponding angles, and they must be equal as the property we have seen. Now these two being corresponding angles and are equal, again I have my angle 1 which is already known to be 110 degrees, and therefore substituting for this I have this to be 110 degrees which is equal to angle phi. Therefore my angle phi is 110 degrees. Angle phi is now found to be 110 degrees is how we get angle phi. Next, let's see how we can find angle 6. The next question is about finding angle 6. Angle 6 is what we are going to find next. To find angle 6. Now clearly I can see that angle phi and angle 6 form a straight line angle, just like angle 1 and angle 2 which form a straight line angle. So I have angle phi plus angle 6 which is clearly equal to 180 degrees, since they form a straight line. They form a straight line. Therefore, phi plus 6 equals 180. Now, we know angle phi is 110, which I am going to substitute here for this. 110 plus 6 is 180. That implies my angle 6 is 180 minus 110, which comes to the right. That implies angle 6 is 70. 180 minus 10, which is 70. Therefore, angle 6, which is 70 degrees, is what we have found using the straight line property, utilizing angle phi. Next is about finding angle 7. So let's see how we can find angle 7 using the properties. To find angle 7, as we can see clearly that 5 and 7 are vertically opposite angles. So let's see if they are equal. Obviously, because vertically opposite angles are equal. Or also we can say 3 and 7 are corresponding angles. So you can either utilize angle phi equals to angle 7 or angle 3 equals angle 7, because 7 acts as vertically opposite angle for phi, and 7 also acts as corresponding angle for 3. So let me take the concept of corresponding angle to find angle 7. Now since 3 and 7 are corresponding angles, angle 3 must be equal to angle 7, since they form corresponding angles. They form corresponding angles. Therefore, angle 3, which is 110 degrees, therefore I substitute for angle 3, which is 110 degrees, equals angle 7, which is already known out in the previous case. So I get my angle 7 to be 110 degrees. This is how I find angle 7 using the corresponding angle. Also, this can be verified for vertically opposite angle, because the angle 7 which I have obtained is nothing but the same as vertically opposite angle phi, which is 110. So vertically opposite angles are equal and corresponding angles are equal can be verified through the values of the angles as obtained. 110, 110, 110, 110. This is how we can cross check on the equality of the respective angles. Angle 7 equals 110 degrees. Next is about finding the last angle, angle 8. Let's see how to find the last angle of the parallel lines. To find the last angle, angle 8. Angle 8 is vertically opposite to angle 6. Angle 8 is corresponding to angle 4. It's our choice to take either the vertically opposite or the corresponding. So I take angle 8, 6 equals angle 8, because since they form vertically opposite angles, they must be equal, and my angle 6, which is 70 degrees, is substituted out here, which is already formed in the previous case. Therefore, this being equal to this, now my angle 8 is 70 degrees. The last angle out here is found to be 70 degrees. Therefore, I have each of the angles which I can find through the given question, which says find the remaining angles for the diagram given out here. This diagram has only one angle which is given, that is angle 1 is 110. Now have all the remaining angles, angle 2 which is found to be 70 degrees, angle 3 which is found to be 110 degrees, angle 4 is 70, angle 5 is 110, angle 6 is 70, angle 7 is 110, angle 8 is finally 70 degrees. Is how we can find the remaining angles of the parallel lines connected with the transversal, strictly using the properties what we have learnt in the previous sessions, connecting with corresponding angles, vertically opposite angles, alternate angles, interior angles, and exterior angles. Real life applications of parallel lines in daily life situations. Now that we have discussed about the parallel lines, the next concept which comes is about connecting the angles in a triangle where all the sides are non-parallel or they intersect each other. So let's see the property connecting the three lines which intersect and form a triangle. As we know that today's topic is about angle sum of a triangle. What is a triangle? A triangle is a three-sided closed figure. As we can see, the three sides are the three straight lines which intersect at three distinct points. Imagine I have three lines which intersect at points A, B, and C. Obviously, the line AB is not parallel to line BC, and line BC is not parallel to line CA, and line CA is not parallel to line AB. Is how we understand the three lines which intersect to form a triangle. Now let's see what is the angle sum in a triangle. There is a property which connects all the three angles in a triangle As we can see, this is angle A, this is angle B, and this is angle C. And mathematics connects these three angles with angle sum in a triangle. Let's see what is the sum of all the three angles in this triangle. So my angle sum property says angle sum property says that in triangle ABC, the angle A, which is denoted by this angle A, and the second angle, angle B, which is out here, angle B, and the third angle, which is out here, plus angle C, must be equal to 180 degrees, is how we connect with angle sum property. Angle sum property defines in a triangle ABC the sum of all angles in a triangle is 180. So this is read as sum of all three angles in a triangle is always sum of all three angles in a triangle is always 180 degrees. Sum equals 180 degrees is how we understand the angle sum in a triangle. Now that we have discussed about the angle sum in a triangle, that is the sum of all the angles in a triangle is equals to 180, let's see the definition of interior and exterior angles in a triangle. A triangle has different types of angles, and let's see in brief about the classification of angles in a triangle. As we see here, here is a triangle. I can clearly extend these lines out here. Then clearly I see that there are different types of angles which I have, say this, this and this. Let me denote by 1, 2 and 3. The triangle A, B and C. Now, as can be clearly seen here, if each of the sides are extended on each of the sides of the triangle, I have the other set of angles which we have out here. So these angles also play a vital role in defining certain properties in the branch of mathematics, especially in the properties related to triangles. So this being extended forms another angle, and here this side being extended forms the other angle, and this side being extended forms the other angle. Let's see how we can connect the properties. Now here we define interior and exterior angles in a triangle. Interior and exterior angles in a triangle. So I have 1, 2, 3 which are interior, and I have 3 exterior angles out here which are 4, 5 and 6. Because they are outside the triangle, angles 4, 5, 6 are said to be exterior, and 1, 2, 3 are inside the triangle. So angle 1, angle 2 and angle 3 are called interior angles. So interior angles are those angles which are inside the triangle, and exterior angles are those angles which are outside the triangle. Is how we understand the triangle concept related to angles, interior and exterior angles. So here interior angles are defined as angles within the triangle. And in this case, angle 1, 2, 3 are interior. In this case, angle 1, angle 2, angle 3 are interior, is how we understand interior angles. Similarly, exterior angles are the angles outside the triangle. So these are called exterior angles because 4, 5, 6 are outside the triangle, and 1, 2, 3 are called interior angles because they are inside the triangle. Angles inside the triangle, interior angles. Angles outside the triangle, exterior angles, is how we understand the concept. Now that we have defined about interior and exterior angles in triangle, let's see the exterior angle property which connects the interior angles in a triangle. This session is about exterior angle property in a triangle. Exterior angle property in a triangle. So let's see the property in brief. Imagine I have a triangle A, B and C. Now here let me take one of the side and extend it so that I take the side BC and extend this side further. Now clearly when I extend one of the side, I get one exterior angle. So this is my exterior angle which I identify. And these are the interior angles, and clearly we know that angle A, angle B, angle C are interior angles in the triangle ABC. So with this interior angles, also I identify that angle A and angle B are interior opposite to exterior. Because these are opposite to the exterior, therefore A and B are interiorly opposite angles. This being opposite to these. Also, angle A comma angle B are interior opposite angles to this exterior angle. And this angle AC, if I extend this to be D, my ACD angle is exterior angle. My angle ACD is exterior angle, and angle A and angle B are interior opposite angles to this exterior angle, angle ACD. So angle A, angle B are specially interior opposite angles to the exterior angle ACD, is how we understand the geometrical concept of each of the properties. Now comes the exterior angle property in a triangle. So as we have the exterior angle and interior opposite angles, the mathematical property which defines exterior angle property is exterior angle property. Exterior angle is equal to sum of interior opposite angles. So if I take this to be 1, 2, 3 and 4, that implies my exterior angle, which is angle 4, must be equal to sum of interior opposite angles 1 and 2. 3 is not interior opposite, but 3 is an interior angle. Exclusively opposite of angle 4 is angle 1 and angle 2. Therefore, exterior angle equals sum of interior opposite angles is what is called exterior angle property in a triangle, which states exterior angle equals sum of interior opposite angles. Now that we have discussed about exterior angle property in a triangle, let's see how we can apply this for the given problems. This session is about applications of exterior angle property. Applications. Imagine I take a problem which has a triangle ABC, which is produced out here. Then I have this to be (140) and this to be 30 or 60. Now my question is about finding this angle B or even this. So here my question says find the remaining angles in the triangle ABC. So here is the triangle ABC in which I had to find the remaining angles, that is angle B and angle A. So let's see how we can connect exterior angle property to this problem. Now clearly angle C is given to be 60 degrees and the exterior angle at A is given to be 140 degrees. So assuming this to be exterior angle, now I try to identify the interior opposite angles. This being the exterior angle, its interior opposite angles are this and this, as clearly can be seen. So angle B, angle C are interior opposite angles, and my exterior angle out here is BAD, which is 140 degrees. BAD, which is 140 degrees. Now this being 140, let's see how we can use the property. Clearly, we know that the exterior angle property says from exterior angle property, exterior angle equals sum of interior opposite angles. being angle B and angle C is how we get exterior angle property. Now this exterior angle being equal to 140 degrees as given in the problem, I substitute this with 140 degrees, which is equal to angle B, which we need to find, plus angle C as clearly given to be 60 degrees out here. Therefore, in place of angle C, I substitute 60 degrees, which on further simplification gives angle B is 140 minus 60, which on further subtraction 140 minus 60 is 80 degrees. Therefore, my angle B is found to be 80 degrees. So the angle B using exterior angle property is 80 degrees. Now the question is how to find angle A. As we know the two angles in a triangle, the third angle is 180 minus sum of using angle sum property. So let's see how to find angle A using angle B equals 80 and angle C equals 60. Now here, using angle sum property, angle A plus angle B plus angle C is 180 degrees in this triangle ABC because of angle sum property. Angle sum property is what we get. Now using this, substituting the values of B and C, I get this as angle A plus angle B, which is 80 degrees, plus angle C, which is 60 degrees. Equals 180. That implies angle A is 180 minus 80 plus 60, which on further simplification gives 180 minus 140. That implies angle A is 40 degrees. And now I have my angle A, which is 40 degrees. Therefore, my each angle of triangle is angle A equals 40 degrees as found here, and angle B, which is 80 degrees, which is found using exterior angle property of this, and then angle C, which is 60 degrees given. Using the properties of triangle, we can find the possible angles in a triangle. Is how we connect with applications of exterior angle property and angle sum property in the triangle.